All right, so I'm going to continue on. I'm going to talk about number 13. So you're given L is equal to square root of 2, M is equal to 3 square root of 3, N is equal to the square root of 16, and P is equal to the square root of 9. It says which expression results in a rational number? Here's what they need you to be able to do. They need you to know if you're given radicals, in order for it to be a rational number, the radical, you'll be able to come out with a nice integer for them. So square root of 2, if you try that on your calculator, it's like 1.14 or something like that. 3 square root of 3, again, that's not going to come out with a nice integer. But square root of 16, what's the square root of 16? The square root of 16 is 4. Square root of 9, what's the square root of 9? What times itself equals 9? Oh, that's 3. So N and P are the ones that are going to help you to get to rational numbers. So let's go ahead and take a look. Here, if you look at L plus M, well, L plus M, L is the square root of 2, plus M is the 3 square root of 3. Those don't have a shot because you can't come up with nice integers for square root of 2 or square root of 3. So that doesn't have a shot. 2m plus n, well, as soon as you have a 3 square root of 3, you don't have a shot. But let's look at 3, n plus p. So even if you start in the original form, n is square root of 16 plus p is square root of 9. Square root of 16 is 4 plus square root of 9 is 3. 4 plus 3 is 7. That's a rational number. A number is rational if it can be written as a fraction. Well, could I write 7 as a fraction? Sure, 7 over 1. So 7 is absolutely a rational number. So if you add n plus p, you'll come up with a beautiful rational number. That's all they want. They're really testing is, do they understand that if you come up with a nice square root, it's a rational number, but if you can't come up with a nice whole number for your square root, it's not going to be rational. I hope that helps. Let's move on. This one, number 16, you had asked about. It says, John has 4 more nickels than dimes. 4 more nickels than dimes in his pocket for a total of $1.25. Which equation could be used to determine the number of dimes x in his pocket? So they tell you to let x equal the number of dimes in his pocket. They give that away. Determine the number of dimes x. You're also talking about nickels here. So let's see if we can figure out nickels. He has 4 more nickels than dimes. Well, his dimes is x, and he has 4 more nickels than dimes. So if you know x is your number of dimes, and he has 4 more nickels than dimes, x plus 4, number of dimes, 4 more nickels than dimes, x plus 4 more would be his number of nickels. He has 4 more nickels than dimes. All right. Anytime you have one of these, they want you to write an equation, they give you the value of $1.25. You have to go back up here and you have to say, okay, if x is our number of dimes, what's our value of dimes? Well, 1 dime is 10 cents. So if x is your number of dimes, what's your value of dimes? You just take your number of dimes and you multiply it by the value of 1 dime. 1 dime is 10 cents. Then you need to know your value of nickels. Well, if you know 1 nickel is 5 cents, you have x plus 4 is your number of nickels. What's your value of nickels? You just take 5 cents, what 1 nickel would be, and you multiply that by the number of nickels you're given. You're given x plus 4 nickels. And then what would you do to find your total amount of money you have? You're just going to add those up. So you'll add up your value of dimes and your value of nickels, and that better be $1.25, because that's what they tell you. So let's see what one. Number 2. These don't even have a shot. And this one, the issue would be the student accidentally multiplied the value of dimes by the number of nickels. So it's number 2. Hope that helps. Let's move on. Let's take a look at number 21. On number 21, it says a sunflower is 3 inches tall at week 0 and grows 2 inches each week. The function, which function or functions shown below can be used to determine the height f of n of the sunflower at n weeks. Okay, so n is your number of weeks. Oh God, that's the worst line I've ever drawn. Oh well. F of n is your number of, can be used to determine the height. F of n is the height. So that's going to be the height of your plant. And they just give us some information. They say at week 0, it's already 3 inches. So you bought the plant, it was already 3 inches tall. Then it grows 2 inches each week. So after a week, if it started at 3 inches, it grows 2 inches, you're now up to 5. After 2 weeks, all right, started at 3 inches, grew 2 inches to get up to 5, 2 more inches the next week, now you're up to 7. Let's say after 3 weeks, 7 and 2, now you're up to 9 inches for the height. So what we really want to be able to do is figure out which one of these functions, if I plugged in 0, 1, 2, 3, I could come up with the height after n weeks. So let's take a look at the first one. F of n equals 2n plus 3. Well, let's test it out. If I plugged any one of these numbers in place of n, if I multiplied 2 by it and added 3, would I come up with this value? So let's just try for n equals 0. 2 times 0 plus 3. 2 times 0 is 0 plus 3 is 3. All right, when I plugged in a 0, I got out a 3. I feel good about that. So now let's do 2n plus 3, but this time let's substitute in a 1. 2 times in place of n, let's put a 1. 2 times 1 plus 3. 2 times 1 is 2 plus 3. Oh, yay, that's 5. Let's try for 2. 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. Well, this sure does seem to be working. And then finally, 2 times 3 plus 3. 2 times 3 is 6 plus 3 is 9. Absolutely. If you take any one of these n values, you multiply it by 2, and then you add 3, you're going to come up with the height. And that makes sense. It starts at a height of 3, and it grows 2 inches each week. So 1 definitely is going to work. Let's try the next one. 2n plus 3 times n minus 1. Let's go ahead and just substitute 0 in, and let's see what happens. 2 times 0 plus 3 times 0 minus 1. It would have to work for every one of these values. So I'm going to substitute 0 in place of here. Working within parentheses, 0 minus 1 is negative 1. So this is 2 times 0 plus 3 times negative 1. 2 times 0 is 0. Plus 3 times negative 1 is negative 3. 0 plus, that's negative 3. We need to get a positive 3 out. So that tells me 2 doesn't have a shot. Let's try the next one. Let's try f of n minus 1. This is a recursive plus 2. And they tell you f of 0 is 3. Okay, so let's substitute a 1 in. So this is f of 1 minus 1 plus 2. So if I substitute a 1 in place of n, I'm hoping to get a 5 out. 1 minus 1 is 0, so that's f of 0 plus 2. They tell us f of 0 is 3. So that's 3 plus 2 is 5. So when I substituted a 1 in, I got out a 5. That feels pretty good. Let's try substituting a 2 in. F of n minus 1 plus 2. So now we're going to do f of, in place of n, I'm going to put 2. 2 minus 1 plus 2. That would be f of 2 minus 1 is 1 plus 2. Ooh, what's f of 1? Oh, when I plugged a 1 in for f, I got out a 5. So f of 1 must be 5. So this would be 5 plus 2 is 7. Yay, when I plugged in a 2, I got out a 7. This is just a recursive. And trust me, when you plug in a 3 here, this would be f of 3 minus 1, 2, plus 2. Well, f of 2 is 7, plus 2 more gets you to 9. 3 absolutely works. So the answers are 1 and 3. The only one that doesn't work is 2. 3 is a recursive rule, and the first one is just a regular old function rule to represent that table. I hope that helps. I'm not sure. All right, the next one, number 23. You only got a couple more you had questions on. The formula for the volume of a cone, volume equals 1/3 times pi times r squared times h. The radius r of the cone can be expressed as. So all they're telling you, if they give you this and they say express the radius r, they mean solve the equation for r. This is a literal equation. V equals 1/3 times pi times r squared times h. Trying to get r all by itself. Well, how can I get rid of the 1/3? To get rid of the 1/3, I could multiply both sides of the equation by 3. I'm going to multiply the right side of the equation by 3. I have to multiply the left side of the equation by 3. 1/3 times 3, bye-bye. So now I have 3v equals pi times r squared times h. I'm trying to solve for r, so I'm going to undo these multiplications. Try to get r by itself. How do I undo this multiplication? Oh, I could divide by pi. How do I undo this multiplication? Oh, I could divide by h to get r by itself, r squared by itself. If I'm dividing this side by pi h, I have to divide the other side by pi times h. Bye-bye pi, bye-bye h. 3v over pi h equals r squared. Whew, I'm trying to get r by itself. How do I undo a square? Oh, I take the square root. Got to take the square root on both sides. Square roots and squares, those are inverse operations. I'm left with r equals the square root of 3v over pi times h. That's solving that literal equation for r. So 3v over pi h, taking the square root of that, it must be number 1. Let's see, the video will run out after 15 minutes. Let's hope I can do the last one. All right, the diagram below represents the first 3 terms in a sequence. To give you a beautiful picture, assuming the pattern continues, which formula determines an, the number of shaded squares for the nth term? So what you have to do is here, the n, it's the number of the term. And then I just like to make little tables. It usually helps me. An would be the number of shaded squares. So this is our first term. So if n is 1, how many shaded squares do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, there was 12 shaded squares there. Next one, second term. Second term, how many shaded squares are there? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, there's 16. Next one, third term. We have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Whew! All right, I'm going to try to show you this real quick. You could substitute in to prove which one it is, but if every time 12 plus 4 is 16, 16 plus 4 is 20, repeated addition means multiplication. So I know this will be 4n plus, I wish I knew what my 0 term would be. Well, my 0 term, if I backed it up, 12 minus 4 would be 8. It's actually going to be 4n plus 8 will give you an. I'm going to run out of time, but I can also tell you, you could guess and check this. Plug a 1 in place of n. 4 times 1 plus 8. 4 times 1 is 4 plus 8 is your 12. Plug a 2 in place of n. 4 times 2 plus 8. 4 times 2 is 8 plus 8 is 16. Plug a 3 in